The P0133 code indicates a slow response from the oxygen sensor, specifically Bank 1 Sensor 1. This sensor monitors oxygen levels in your exhaust to ensure the optimal air-fuel mixture. A slow response means the sensor isn't reacting quickly enough to changes in exhaust gases. This can lead to poor fuel efficiency, increased emissions, and potential engine damage. It's a common issue in older gasoline vehicles, but less so in newer hybrids and electric vehicles. As of 2025, this can still be prevalent in vehicles manufactured pre-2015. Sensor degradation is a common cause of the P0133 code. Contamination from oil, coolant, or fuel additives can foul the oxygen sensor, slowing its response to changes in exhaust gas composition. Electrical issues can also trigger the P0133 code. Corroded wiring, poor connections, or ECU faults disrupt the signal transmission from the oxygen sensor to the vehicle's computer. Exhaust leaks before the oxygen sensor can dilute the exhaust gases, affecting the sensor's readings and causing the P0133 code. Engine problems such as vacuum leaks, faulty fuel injectors, or low compression can cause erratic oxygen sensor behavior, leading to the P0133 code. Check for physical signs of these issues. Start by scanning your vehicle's computer for the P0133 code using an OBD2 scanner. Also, look for related codes like P130 through P0135. Use an oscilloscope to check the O2 sensor's waveform. A healthy sensor will show frequent oscillations. A slow response will appear sluggish. Note that modern sensors should have a response within 100 to 200 milliseconds. Delays indicate failure. In 2024, OEMs integrated AI-driven software allowing real-time sensor health monitoring. Begin by inspecting the wiring and connectors for corrosion or damage. Use the images to identify issues like corroded contacts that can cause signal problems. Clean or replace components as needed to ensure proper electrical connections. Next, inspect the exhaust system for leaks before the O2 sensor location. Leaks can introduce extra oxygen, causing false readings. Use the exhaust system diagram and sensor socket image to guide your visual check. If the sensor is degraded, replace it with a compatible one for your vehicle. Use the socket wrench image to show the removal process. Ensure proper installation to restore accurate sensor response. Finally, address any underlying engine problems like vacuum leaks, faulty injectors, or low compression. Use the images of solenoids, injectors, and compression tests to identify and fix these issues for complete resolution. Oxygen sensor replacement typically costs between $50 and $300, including labor. This cost covers the new sensor and professional installation to resolve the P0133 code. Newer sensors from manufacturers like Bosch and Denso include integrated heating elements and digital interfaces. These advancements reduce response delays by up to 50%, improving engine performance and emissions control. When replacing the sensor, ensure it's properly torqued to prevent exhaust leaks that could trigger the code again. After replacement, clear the P0133 code using an OBD2 scanner and monitor the vehicle to confirm the sensor responds within 100 to 200 milliseconds. For advanced diagnostics of the P0133 code, use a multimeter to check the oxygen sensor's voltage output. Attach the probes to the sensor's signal wire and ground. Then compare the readings to the manufacturer's specifications for normal voltage range. Visualize the sensor's response with spark lines. A healthy sensor shows rapid oscillations between 0.1 volts and 0.9 volts, while a slow response appears as sluggish changes. Telematics platforms are becoming prevalent for proactive diagnostics. These systems monitor sensor data in real time through connected vehicle technology, alerting drivers to potential issues like slow oxygen sensor response before the P0133 code triggers. AI-driven software integrates predictive diagnostics by analyzing sensor patterns. Using historical data, AI can predict when an oxygen sensor might fail, allowing for maintenance before problems occur. A common mistake is misdiagnosing the P0133 code as a faulty oxygen sensor when it's actually a wiring problem. Experts report that about 30% of these codes stem from wiring issues rather than sensor failure. Before replacing the sensor, always perform a thorough inspection of the wiring harness, connectors, and electrical connections for corrosion, damage, or loose connections. Another frequent error is ignoring exhaust leaks, which can trigger false positive P0133 codes. Leaks before the oxygen sensor dilute the exhaust gases, causing the sensor to detect an incorrect air-fuel mixture. Always inspect the exhaust manifold, pipes, and gaskets for cracks, holes, or damage. Use a smoke test or visual inspection to identify leaks and repair them before assuming sensor failure. Don't assume contamination is the cause without checking. Oil, coolant leaks, or poor fuel quality can foul the sensor's electrodes. Perform a visual inspection and use proper diagnostic tools like multimeters before concluding sensor failure. As electric vehicles continue to dominate the market, the prevalence of P0133 codes is steadily declining. Innovations in sensor technology include solid-state sensors that provide zero-latency response times. These advanced sensors are designed for compatibility with emerging hydrogen and biofuel engines. However, supply chain challenges for materials like platinum can drive up replacement costs. Sustainability is becoming a priority, with manufacturers focusing on recyclable sensor components. Soon, oxygen sensors will become niche technology found only in older legacy vehicle fleets.